Quickly turn on videos of static assets basis.
Ma'am, you're breaking up.
Okay. To see what is an asset, what is it not. Matching up. Is it better now? Are you all able to hear me now? Better? Yeah. Okay. Okay. Now we have different materials in nature, okay, that have different taste, okay, that have different taste. The reason behind that is they contain different
You're breaking up
yes,
again.
my voice is breaking again.
No, now it's fine.
Now it's fine. Okay. Okay. So now these chemical substances are acidic or basic in nature. Okay. So we will understand what are acids and bases. Okay. Now, some substances are sour to taste. Okay. Some substances are sour to taste, such as curd, such as lemon juice and vinegar. When we taste them, we feel that they are sour. Okay. Why these substances taste sour is because they contain acids. Okay. They contain acids. The chemical nature of such substances, which we may find sour in taste, is acidic. Okay. Lemon juice, vinegar, curd, tamarind. Okay. These are all substances with a sour taste. Okay. And they are acidic in nature. Okay. Whereas some substances are there which are bitter in taste. For example, baking soda. Okay. Baking soda is bitter in taste. And if you mix baking soda in water and you rub it between your fingers, you will feel it soapy texture. The same when you do it with a soap or a, detergent powder. Okay, that texture you will feel with baking soda also. Why? It is because baking soda is a base. Okay, it is a substance known as a base. Okay, now see, these substances such as curd, lemon juice, vinegar, baking soda, detergent powder, and color. Okay, I will get interested group. Yes, Hannah.
Ma'am, your voice is breaking again.
My voice is breaking again. Okay, just a minute. Therefore, some substances are acidic and some substances are basic in nature. Okay, now, now see how to differentiate between what are the main differences between acidic and basic substances. Okay, both are chemical substances, but the main difference is one is the taste, one is the taste. Okay, acids are sour in taste, whereas bases are bitter in taste. Okay, acidic substances are sour in taste, basic substances are bitter in taste. Number two is the texture. Okay, basic substances will feel more soapy. Okay, basic substances will feel more uh, soapy. Okay, when you touch them. All right. But also there are also some substances which are neither acidic or basic. Okay, some substances which are neither acidic nor basic. Those substances are known as neutral substances. Okay, neutral substances. Those substances which are neither acidic nor basic in nature, just normal. Okay, they are not acidic also, not basic also, normal. Okay, these are known as neutral substances. Okay, now, now we cannot taste every substance to check whether it is acid or base. Okay, because everything is not edible. Okay, can you taste soap and tell if it is acidic or basic? Can you eat detergent powder and tell acidic or basic? No, we cannot do that. We cannot taste, or we cannot taste vinegar also directly on the tongue. Okay, because it is very concentrated. We can put it in salads and all, but not directly on tongue because it is quite, concentrated. Okay, so that is why we cannot eat or taste everything and tell if it is sour or bitter or if it is acidic or basic. So how do we check? How do we test if a chemical substance is acidic or basic? There is something known as a litmus test. Okay, a litmus test, or there are some substances through which you can test, are called indicators. Okay, they are known as indicators. What happens in these indicators is that when you put them, or when you put an acid or a base on them, they change color. Okay, they change color. So with that change of color, you can tell if it is an acid or a base with the help of that change in color. Okay, now special types of substances are used to test whether a substance is acidic or basic. These substances are called indicators. The indicators change color when added to a solution containing an acid or a basic substance. Okay, some examples of indicators are turmeric, litmus, China rose petals, etc. Okay, so see, now try to understand this. Okay, um, there are two types of indicators. Okay, some things are natural indicators, some things are um, man-made indicators. Okay, for man-made indicators, there is a thing called a pH indicator. Okay, there is a thing called a pH indicator. Okay, so, and there are some natural indicators also. What are natural indicators? Natural indicators are those substances which occur naturally in nature, which are grown in nature, which we get from nature. They are not man-made, they grow naturally and we use it from nature directly. Okay, such as turmeric. Turmeric is a natural indicator. Litmus. Litmus is a natural indicator. And China rose petals. China rose flower, if you've seen a China rose flower, okay, the petals of that flower is also a natural indicator. Okay, these are natural indicators. Man-made indicator, I'll show you how it looks, what it looks like. Okay, This is pH indicator universal. Okay, this is pH indicator universal, and there is colors you can see on one side. Okay, various colors you can see on one side. So when you dip this yellow strip in various substances, according to that it will change color. Okay, according to that it will change color, and it will show you if your substance is acid or basic, or very acidic or very basic. Okay, now take a look at this image. Okay, in this image, if you take a yellow color strip, okay, and it changes to red. If the yellow strip changes to red, okay, red color indicates acid. Okay, red color indicates acid. If it is very dark red, it is gastric acid. Lemon juice red, apple juice red, tomato juice orange. Okay, milk is white. Okay, sorry, yellow. Milk is yellow because some things are neutral. Okay, the things such as water. Okay, these are neutral. Water is neutral. Water is not acidic or basic. Okay, then moving on to basic substances, you have baking soda, you have hand soap, ammonia solution, bleach, and concentrated solution of alkalis, acid. They'll eventually turn very dark, that is purple from blue. Okay, green it will turn for baking soda, hand soaps, blue for bleach and all, and then eventually purple if it is a very strong base. Okay, so this is how we check with a pH indicator. Okay, with an indicator that if it is an acid, if it falls in the orange and red category, it would suggest you an acid. If it is very dark red, then a strong acid. If it goes on to a very dark blue or purple, then a strong base. Okay, if it goes to green and all, then it indicates hand soap. Okay, so this is how we check with litmus paper if it is red, or with a pH scale with a pH paper if it is an acid or a base. Okay, understood. That is about your pH scale. Okay, now this is an activity in which you have to taste these things and you have to write if their taste is sour, bitter, sweet, or any other. Okay, if their taste is sour, bitter, sweet, or anything else that you can do. You can check out this activity. Okay. After that, we'll talk about some of the indicators in detail. Okay. This is lichen. Okay. This is lichens, and the litmus is extracted from lichens. Okay. These litmus strips are extracted from lichens. Okay. Red and blue litmus paper. Red and blue litmus paper is made up of lichens. All right. If you are using a litmus paper that is red, or blue litmus paper that is made up of lichens. Okay. Now, the most commonly used natural indicator is litmus. It is extracted from lichens. It has a mauve purple color in distilled water. When added to an acidic solution, it turns red. When added to a basic solution, it turns blue. Okay, so this purple color, when added to acidic solution, okay, a litmus, when you add an acid to a litmus, or when you put a litmus to an acid, it will turn red in color. And when you add it to base, it will turn blue in color. This you have to remember, okay? It is always asked in the exam. This you have to remember. Litmus paper, when does a litmus paper turn red, or when does a litmus paper turn blue? So litmus turns red when it is added to an acid, and it turns blue when it is added to a base. Okay, all right. Then it is available in the form of a solution or in the form of strips of paper known as litmus paper. Generally, it is available as red and blue litmus paper. Acid turns blue litmus to red. while base turns red litmus to blue. Okay, if it is acid, it will turn the blue litmus paper to red. Okay, acid. If it is a base, it will turn a red litmus paper to blue. Base. Okay, so this thing you have to remember. This thing, this turning, which color is turning in what? That thing you have to remember. Okay, next. Mix some water with lemon juice in a plastic cup or tumbler. Add small amount of water to it. Put drop of this on a strip of the red litmus paper. Is there any change in color? Repeat the same exercise with other substances and write your experience. When we are meeting in the next, after finishing this chapter, when we will be meeting, we will do litmus test at home. Okay, we will be doing litmus paper test at home. I will teach you to make your own litmus paper at home. Okay, and everything that we will use is already available at your home, so you don't have to purchase anything extra, but we will make our own litmus paper and come in the class, and in the class we will do litmus experiment. Okay, with detergent solution, lemon and all right, so once we finish this chapter, we will be doing the litmus experiments. Now, then we have turmeric, which is also a natural indicator. Okay, take a tablespoon of turmeric powder, add a little water and make a paste. Make turmeric paper by depositing turmeric paste on blotting paper or filter paper and drying it. Cut thin strips of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. Okay, what do you observe? Soap solution is basic. Hence, the turmeric strip will turn red. Okay. Now repeat the same exercise with other solutions and write your experiences. This is the activity we are going to try out in class. Okay. All right. Now, China rose, which is also a natural indicator. Collect some China rose petals and place them in a beaker. Add some warm water. Keep the mixture for some time till water becomes colored. Use the colored water as an indicator. Add 5 drops of the indicator to any solution and see the effect. China rose indicator turns acidic solution to dark pink and basic solutions to green. Okay, we can also check this out. Prepare these natural indicators and try to observe the change in color in acidic, basic, and neutral solutions. Okay, neutralization. When an acidic solution is mixed with a basic solution, both the solution neutralize the effect of each other. Now, what we are talking about is neutralization. Okay, means something which is, not neutralization. Basically, is when you mix an acid and a base. Okay, they cancel each other out. They cancel each other out, and their effect is nullified. Okay, or their effect becomes zero. Okay, when an acid and a base, okay, is mixed together, both the solutions neutralize the effect of each other. When an acid solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. Okay, when acid solution and base solution is mixed together, the acidic nature of the acid and the basic nature of the base both is destroyed. Okay, in this reaction, heat is produced. Okay, in neutralization reaction, a new substance is formed which is called salt. Okay, in neutralization reaction means when an acid and base is combining, there is something which is formed which is salt. Okay, and heat is also produced in this reaction. All right, so the reaction between an acid and a base, the reaction between an acid and a base is known as neutralization. Salt and water and heat. Salt and water produced in this process with the evolution of heat. Okay. See, acid plus base gives salt plus water and heat also. Okay. Following reaction is an example. HCl, that is hydrochloric acid, when it is mixed with sodium hydroxide, that is NaOH, will give NaCl. Okay, sodium chloride plus water, H2O, and heat. Okay, NaCl is salt. NaCl is salt. Okay, this is acid, acid, base is giving salt plus water and heat. Okay. Neutralization is also very important from the exam POB. Okay. Neutralization is also an important concept, important topic. Now, neutralization reaction is something very common in our daily lives. Okay. It's something that's very common in our daily lives. Okay. See, some salts are generally used in our homes, like baking soda. Okay, baking soda is, baking soda, washing soda. These are all salts made up by a mix of an acid and a base. Okay, baking soda. Its chemical name is sodium hydrogen carbonate (NaHCO3). Okay, and washing soda, which is also used in our home, its chemical name is sodium carbonate Na2CO3. And bleaching powder is also used in our home. Chemical name calcium oxychloride CaOCl2. Okay, calcium oxychloride, which is also used in homes. Okay, so these things are there commonly used salts, which are there in our home, which are used in our home. Okay, all right. We will stop here for today. Okay, I'm going to stop here for today. And the homework for you is 8.3, exercise 8.3 is homework for you. When we'll be meeting on Monday, I'll be talking about examples of neutralization in everyday life. And then we'll just finish the back exercises in the chapter and we'll start a new lesson after in the next week. Okay. Now, uh, one duty I'm giving to one of you today. Okay. One duty I'm giving to one of you today. The duty is to post every day's homework in the group. Okay. The duty is to post every day's homework in the group. The PDFs are available. You can just take a screenshot. Okay. Whatever homework I am giving you, you can also take screenshot from here, from my screen, and you can post it in the group as today's homework. Post science and maths homework. Write down today's homework. Okay. For the remaining days of this month and the next month, Johanna will be doing it. Okay. Then after that, I'll change it to somebody else, and for like one month rotation we will do. Okay. One month rotation we will do. So Johanna,
Also,
yes, Johanna.
this whole June I should send homework.
Yes, like the few days of this June and then the July also. Okay. The month of July also you have to do it. And then in the month of August, I will change it to somebody else. Okay. Then in September, somebody else. So rotation we will do. Okay. One month rotation we will do. So Johanna can post till the end of July. Then after that, August, I'll give it to somebody else. Okay. Like that we are going to do. So Johanna, please post today's homework in the group, science and maths both. All right. Okay. Okay. We'll stop here for today. And we will be having a 5-minute break. After that, we'll be starting with maths class. Okay, let's begin. Johanna, Zoe, hope y'all are there too. Okay. All right. Today we will be discussing how to convert uh
Excuse me, ma'am.
yesterday. Yes,
Ma'am, I can't see a whiteboard again, ma'am.
you cannot see my whiteboard again.
Yes, ma'am.
Johanna and Zoe can see. I think you're having some network issue, Hannah.
Yes, ma'am. Here we don't have enough network, ma'am. It says collaboration server handshake failed.
Okay. Hello, Joshua. Good morning.
Ma'am, good afternoon, ma'am.
Hello. Would you on, please, Joshua? Are you able to see the note screen, Hannah?
Yes, ma'am.
The white screen? Okay.
Yes, ma'am.
Uh, so, today I'll be teaching you how to convert a percentage. Yesterday we saw how to convert a percentage to fraction. Today we will see how to convert a fraction to percentage. Okay, converting fraction to percent. Okay, we will convert a fraction to a percentage. Now this method is very simple. Okay, this method is very simple. For example, let's take a fraction. Let's take a fraction 3 by 4. Okay, 3 by 4, or let's take 3 by 5. What we will do, what we will do is that we are going to change it or multiply this fraction with 100 upon 1. Okay, you will multiply whatever fraction that you have with 100 by 1. Okay, why 100 by 1? Because we can take 100 in the form of a fraction because we're working out with fractions, and we can just take it as 100 by 1. Okay, now now what to do? Now multiply. Okay, multiply it. You can just multiply 300, 100 into 3, 300, 5 into 1, 5. Okay, now you can cancel 5 ones are 5, 5, 6 are 30, and 0. What you will get? 60%. Okay, never forget the percentage sign. What you will get? 60%. Okay, that is how you solve this. Okay, now take a look at one more example. One more example. 16, sorry, one whole number, 7 upon 15. One whole number, 7 upon 15. Now what is this? What is this? It is a mixed fraction. So first we will convert it to an improper fraction. Okay, first we'll convert it to an improper fraction. 15 ones are 15, 15 into 1, 50, plus 7, 22 upon 50. Okay, 22 upon 15. Now we will do 22 upon 15 into 100 upon 1. Okay, 22 upon 15 into 100 upon 1. So straight away we can multiply 22 into 100, 2200, 2200 upon 15. Okay, divided by 15. Now what we will do is that we will cancel this, okay, by 5. Okay, we can cancel this by 5. So 5 3s are 15. Okay, 5 3s are 15. 2200 divided by 5, you will get 440. Okay, so what we will get? 440 by 3. Can it be cancelled more? No, it cannot be cancelled more. So you can just write 440 by 3%. Okay, you can write it as 440 by 3%. And if you wanted to convert, if you want to convert it to um, mixed fraction again, you can convert it like this. Okay, I will show you. 440, 440 by 3. Okay, we will divide by 3. 3 ones are 3, right? 3 minus 1, 4 minus 3, 1. Okay, bring down 4. Okay, how much? 3 4s are 12, because 3 5s are 15 is greater. 3 4s are 12. 12, 4, 14 minus 12, 2. Okay, then bring 0 down, 0 down. Then in the table of 3, 3 5s are 15, 3 6 are 18. 3 6 are 18. Okay, 2 will be the remainder. Okay, now how to convert this division into a mixed fraction? It is like this. Okay, um, 146, 146 comes here, 3 goes bottom, 2 goes up in the form of circle. Okay, 2 goes up, 146 to the side, and 3 to the bottom. So what it becomes, how can I write it? I can also write this as, or either you can just do 440 divided by 3%, or you can write it as 146 whole number 2 by 3%. Okay, 146 whole number 2 by 3%. All right. Okay, so either you can just leave it as 440 by 3%, or you can divide it and more and write it as 146 2 by 3%. Both answers are correct. Okay, both answers will be considered correct. So any way you want, you can write it. Okay, I'll just explain what I did here once again.
Excuse me,
Okay,
ma'am.
yes, Hannah.
Ma'am, does this question mean that every mixed fraction will turn into a fraction only, ma'am, without a whole number?
Yes, Hannah. Yes. Mostly, most improper fractions will turn into fraction only. Like the answer you will get will be in fraction only most of the time.
Ma'am, not
Okay.
improper, ma'am, mixed fraction.
Mixed fraction. Hannah, you can just leave it till here also, or you can use mixed fraction also. Both
Ma'am,
answers are correct.
ma'am, I
Yes.
mean the upper question, we got the answer 60%, ma'am. But
Mhm.
in this, we got a fraction and a percentage as an answer. So does that mean every mixed fraction will only come into a fraction percentage?
Every mixed fraction will mostly come into a fraction percentage. Okay. Until this thing is fully dividing. Okay, if this thing is fully canceling out, fully dividing, you will get a whole number also, Hannah. Okay, depends on the question, Hannah. Okay, you may as well get a whole number if the numbers are fully dividing with each other. If it is fully canceling out, you will get a whole number. If it is not canceling out, then you may just get a fraction. Okay, it depends on the question if you get a fraction or a whole number. Okay, converting this divide into mixed fraction, 146, put it to the side. 3, bring it down. 3, you will just bring it down. And 2, you will take it up. Okay, like in a circular manner. This way you will convert it into a mixed fraction. Now, one more question I will show you when you have a decimal. Okay, when you have a decimal, 0.7, you have to convert it into percentage. Okay, 0.7. If it is in points, what will you do? First thing, you will remove the point. Okay, when we remove the point, we will put 1 and a 0 with it up to how many decimal places are there after the point. So I will write 7 upon 1, and 1 is 7 is only one digit after point. So 7 upon 10. Okay, means 10. If there were two decimal places after the point, means if it was two digits here, it would be upon 100. If it is three digits here after the point, upon 1000. Okay, like that. All right, like that we do. But it is only one digit, so we just write 7 upon 10 into 1 by 100. Sorry, 100 by 1. Okay, 100 by 1. You do. Same process, then you just can cancel 0 with 0 and multiply 7 with 10. What you will get? 70. You will get 70%. You will get 70% as the answer.
Yeah, ma'am.
Then, ma'am.
Okay. My pen is not working. Okay. One question I will give you. One question I will be giving you. Try this out.
Ma'am, is this for question for us to do?
Yes, Anand. This question is for you to do.
I sent you an answer.
Okay, Joshua. It's correct, Joshua. Four 100%. How come, Hannah?
Ma'am, I sent you my answer.
Okay. Today I'm having some network issue. It's not working.
Ma'am.
Can you just say the answer, Hannah?
Yes, ma'am, I got 400%.
Okay, Zoe also sent me something. Zoe? Oh, you also did some tests using pH indicator. That's great. That's great, Zoe. See, 8 upon 20 multiplied by 100 by 1.
Ma'am, I did 8 by 2, ma'am.
That is the reason, Hannah. It's 20. Four into 10, 40% you will get. Hope everyone is getting the answer, 40%.
Yes, ma'am. Ma'am, I have read it, ma'am. I got the same.
Okay. All right. Any doubt in the question? Any doubt in this topic? Uh, Now I'm going to show you how to calculate a given number of a particular percent. Okay, for example, the question is 160, 160 is what percent of 200. Okay,
Ma'am, you have to
meaning
do
it.
this question.
No, I will teach you first and then I will give you to do. Okay, 160 is what percent of 200? We need to find out like this. Okay. So what you do in that case is, what you do in that case is this. You will divide 160 with 200 and multiply it with 100. Okay. 160 means the number upon the total 200 into 100. Okay, so you cancel 0, 0, 0 with 0 and 0. 2 ones are 2, 2 eights are 16 and 0. Okay, how much will you get? 80%. Okay, 160 is 80% of 200. Okay, 160 is therefore 80% of 200. Okay, one more question we will do. Okay, one more question we will do. 3.5 kg. Now, when it comes in points, what to do? 3.5 kg is what percent? Is what percent of 25 kg? 3.5 kg is what percent of 25 kg? What we will do is first just write it down as it is 3.5 upon 25 multiplied by 100. Okay. Now see, the decimal point is there. So what we will do is to remove the decimal point, we will put a 0 after 25. So 35 upon 250. Okay, you know that after one place is there after decimal. So I've put one 0 in the denominator to remove the point of numerator. Okay, now instead of 3.5, it will become 35 and 25. I'll put 10 after it. So it will become 250 into 100 into 100 you'll do. Okay, so now cancel 0 with 0. Okay, 2 5s are 25. 2 twos are, sorry, yes, 5 twos are 10. 5 ones are 5. 5 sevens are 35. Okay, multiply 7 into 2, 14. Answer is 14%. Okay, understood this?
Yes, ma'am.
Okay. Any doubt anyone is having? Now a question for you to do. I'm giving you a question to do. What percent? What percent of rupees 75 is rupees 45? This you have to solve. What percent of rupees 75 is rupees 45? Okay, Joshua. We will solve and see, okay? Any other answers? Zoe, Johanna, Hannah?
Ma'am, I got the answer 60%.
60% you are getting?
Yes.
Okay.
Excuse me, ma'am.
Yes, Hannah.
Ma'am, ma'am, for some time, ma'am, I could not see what you were writing, ma'am. So I repeatedly rejoined again and again.
Okay. Hannah, what I will do is after the class, I will post the class link in the group. Okay. So anytime you're free in the weekend, you can just go back and rewatch the parts you think you missed. Okay. I will
Okay.
post the link in the group, the YouTube link. So whenever you find time, you can just go back and rewatch anything that you want to see again. Okay.
Okay, ma'am.
All right. Yes, Zoe, Johanna, any answers? Shall we do it together now?
Ma'am, I can see your writing now.
Okay. 45 by 75 multiplied by 100. Okay, you can either cancel this out with the table of 5 or you can use the table of 25 also. Okay, 20, for 75 and 100, you can use 25. Okay, for 45 and 75, you can use the table of 5. Okay,
Um,
so
Ma'am, I first multiplied the fractions and then I divided, ma'am. Is that method okay?
first you multiplied the fractions and then you divided. Yes, Hannah. Yes, that is also fine. That is also fine. Not a problem. Okay, let's solve this. We will divide 45 by 3 and it is 15 times 15. Now we will multiply. 15 times 4, 60. 60 was the right answer, Hannah and Joshua. Those who got 60, 60 is the right answer to it. All right. Okay. I will be stopping here for today. Okay. I have to like do some preparations to go out today evening. So I have to make a little bit of preparations. Okay. I'll be stopping here for today. Monday, when we'll meet, I'll start a new chapter with you. Sorry, a new topic with you. A new topic with you, in which we'll be learning how to find out a particular percent of a given value. Okay, how to find a particular percent of a given value. That is what we are going to do on Monday. Okay, one second, I'll just tell you the homework.
Ma'am, did you get my homework, ma'am?
Yes, Joshua, I received your homework. Question 1 and 3 of exercise 8.1 is your homework. Okay,
Ma'am, can you send in the group?
questions. Oh, yes, Johanna will post in the group today. Okay, Johanna, we gave Johanna the duty to post till the end of July. Okay, then we'll change duties. So, please post Johanna. Exercise 8.1, question 1 and 3. Yesterday I gave you question 2. Okay, that's going to be the homework. You can just post this in the group. Exercise 8.1, question 1 and question 3. Okay, that is your homework. All right, that's all for you all today. See you all on Monday. Have a good weekend. Bye.
Bye,
Bye.
ma'am.
Thank you, ma'am. Bye, Joanna. Bye, Hannah. Bye, Zoe.
Thank you, ma'am.